So welcome students. So in this question you're given a sequence. You're asked to find the summation of the sequence up to infinity. Sequence 1 by 4 tan pi by 8, 1 by 8 tan pi by 16, 1 by 16 tan pi by 32, so on. So as you can see, 1 by 4, 1 by 8, 1 by 16, they're getting multiplied by 1 by 2, and pi by 8, pi by 16, pi by 32. These are also angles which are getting multiplied by 1 by 2. So the numbers, the coefficients which are given are in GP, the numbers which are given are also in GP. So if you write the general term of the sequence, so it looks like you have 1 by 2 power n, 1 by 4, 2 power 2 into tan of, you can take pi by 2 as the fixed angle, pi by 2 and have pi by 8 here, that is pi by 2 by 4, it is pi by 2 by 2 power. And n is starting from 2. If n is equal to 2, you have 1 by 4, tan of pi by 2 by 4 is pi by 8. If you have the next term, put n is equal to 3, so 1 by 8, pi by 2 by 8 is pi by 16, so on. So this is the nth term of the sequence. So what I do is I'll add the term which comes before this. If you construct the sequence to one term backwards, so the term that needs to come is 1 by 2 tan pi by 4, right? So 1 by 2 tan pi by 4. So let us try to sum the sequence starting from the first term. So this term is not given. At the last, we'll subtract this term. So let us consider the sequence as, so 1 by 2 tan pi by 4 plus 1 by 4 tan pi by 8 plus 1 by 8 tan pi by 16 plus so on. So what is the nth term of this sequence? Nth term of this sequence is 1 by 2 power n, and starts from 1 now, tan of pi by 2. So let us take pi by 2 as an angle theta. So let us take pi by 2 as theta. So this will be theta by 2 power n. So this will be the general term of the sequence. If you put n is equal to 1, you're getting this. If you put n is equal to 2, you're getting this, so on. Now how do we summate this nth term? So I want the sum of this terms. So Sn is equal to, you have sigma Tn. So to find this sum, what I do is, I'll try to use the formula. I have a formula in trigonometry which says that tan theta can be written as cot theta minus 2 cot 2 theta. You should be familiar with this formula. It's a very standard formula. So tan theta is equal to cot theta minus 2 cot 2 theta. So if you don't know this formula, you have to remember this. You can derive this and remember this. It's very easy derivation. So now you have tan of theta by 2 power n now. So let us try to use this formula. So that is equal to sigma of 1 by 2 power n remains like that. So tan theta by 2 power n, if you have theta here and 2 theta here. So cot of theta by 2 power n, whatever theta is there, you have cot theta minus 2 cot minus 2 cot, this into 2. This angle should be multiplied by 2, that is theta by 2 power n minus 1. So that is equal to sigma. So if I take 1 by 2 power n and give it, if I multiply the brackets, so 1 by 2 power n into cot of theta by 2 power n minus this 2 and 2 power n. So it gets cancelled, 1 by 2 power n minus 1 into cot of theta by 2 power n minus 1. So this is my nth term. This is my Tn. So now this looks like Vn minus 1. So now let us try to expand this. So put n is equal to 1. So what is T1? T1 is nothing but 1 by 2 cot theta by 2 minus 1 by 2 power n minus 1 minus 1 is 2 power 0, 1 by 1 cot theta. And T2 is 1 by n is equal to 2, 1 by 4 cot theta by 4 minus, if you put n is equal to 2 here, so you get 1 by 2 cot theta by 2. Similarly, T3 is 1 by 8 cot theta by 8 minus 1 by 4 cot theta by 4. So on. So what happens if you add these two? What is sigma t power n? As you can see, if you add all these terms, we get cancellations in this direction. So this and this gets cancelled. So as you go on till infinity, these things go on getting cancelled. Okay, so what is Sn? Sn is nothing but, once you cancel all this, Sn is nothing but, so as you get cancelled like this, you have a term remaining here and you have a term remaining here. So what is the term that is remaining here? So if you have T3, you have 1 by 8. So if you go till Tn, you get 1 by 2 power n into cot of theta by 2 power n, that's remaining here, minus cot theta. So these are the things that are remaining. So if you take n is equal to infinity, if you take n tends to infinity, so S infinity is nothing but, so 1 by 2 power infinity, this becomes 0. So 1 by 2 power infinity, so this becomes 0, and theta by 2 power n. So this is 0 into infinity. So we have to find the limit. So S infinity is nothing but limit n tends to infinity 1 by 2 power n into cot theta by 2 power n minus cot theta. So now this is a question of limits. So as n tends to infinity, theta by 2 power n tends to 0. So I will multiply this with theta and divide this with theta. So cot theta by 2 power n can be written as 1 by tan theta by 2 power n, that is equal to limit theta by 2 power n tends to 0. Theta by 2 power n divided by tan theta by 2 power n into theta in the denominator minus cot theta. So because theta by 2 power n tends to 0, so tan theta by 2 power n by theta by 2 power n tends to 1. So this becomes 1. Hence the limit will be 1 by theta minus cot theta. So this will be the value of S infinity. Now let us try to put our theta here. So what is the theta that we assumed? So theta is equal to pi by 2. So 1 by theta is 2 by pi minus cot pi by 2 is 0. So S infinity is equal to 2 by pi. So the sum of this up to infinity is equal to 2 by pi. But you are asked to find only the sum of these terms. So what I need to do is, I have to send this term onto that side. So tan pi by 4 is 1. 1 by 2 into 1 is 1 by 2. So the sum of this is 2 by pi minus 1 by 2. So the sum of this is 2 by pi minus 1 by 2. So this will be the answer to this question. Thank you.